Our moon, a familiar sight in the night sky, holds a shocking secret. Scientists believe it was formed from a catastrophic collision billions of years ago. This collision involved Earth and a Mars-sized object. Imagine the energy released. This theory, known as the giant impact hypothesis, is the leading explanation for the moon's existence. It is a tale of cosmic violence, planetary evolution, and the birth of our closest celestial neighbor. Before the giant impact hypothesis, scientists proposed several theories to explain the moon's formation. One theory suggested the moon formed elsewhere in the solar system and was later captured by Earth's gravity. Another proposed that the Earth and moon formed together from the same cloud of gas and dust. However, these theories failed to explain key characteristics of the moon. The moon's composition, size, and orbit posed significant challenges to these early explanations. In the 1970s, a new theory emerged that revolutionized our understanding of the moon's origin. The giant impact hypothesis proposes that a Mars-sized object named Theia collided with the early Earth. This catastrophic event released an immense amount of energy, vaporizing Theia and part of Earth's mantle. The resulting debris, a mixture of molten rock and vaporized material, was ejected into orbit around Earth. Over time, this debris coalesced under its own gravity, eventually forming the moon. The giant impact hypothesis is supported by a wealth of scientific evidence. The moon's heavily cratered surface is a testament to the violent bombardment it experienced early in its history. This bombardment likely included leftover debris from the initial impact. Moreover, analysis of lunar samples brought back by the Apollo missions revealed striking similarities between the composition of the moon's crust and Earth's mantle. This supports the idea that the moon formed from material ejected from Earth's outer layers. Leading scientists around the world have embraced the giant impact hypothesis. Dr. Caroline Porco, a planetary scientist known for her work on the Cassini mission, states, "The evidence for a giant impact origin of the moon is very strong." Dr. Porco emphasizes the importance of lunar samples in confirming this theory. Dr. David Stevenson, a planetary scientist at Caltech, adds, "The giant impact is the only scenario that can explain the major features of the Earth-Moon system." Dr. Stevenson highlights the unique characteristics of our moon that set it apart from other moons in the solar system. Section 6. Understanding lunar evolution. The giant impact hypothesis has profound implications for our understanding of lunar evolution. The intense heat generated by the impact would have melted the moon's surface, creating a global magma ocean. As this magma ocean cooled and solidified, it formed the moon's initial crust. The impact also likely played a role in shaping the moon's internal structure. The differentiation of the moon's interior, with a dense core and a lighter mantle, is thought to have been influenced by the energy and material exchange during the impact. Section 7. Implications for planetary formation. The giant impact hypothesis has broader implications for our understanding of planetary formation. Giant impacts, like the one that formed the moon, may have been common in the early solar system. These collisions played a crucial role in shaping the planets and their moons. The study of the moon's formation provides valuable insights into the processes that govern the formation of our solar system. By understanding the moon's history, we gain a deeper understanding of the history of our own planet. Section 8. Key points about the moon collision. The giant impact hypothesis proposes that the moon formed from a collision between Earth and a Mars-sized object. This theory is supported by evidence such as the moon's cratered surface and the composition of lunar samples. The impact had a profound impact on lunar evolution, shaping its surface, internal structure, and orbit. The study of the moon's formation provides insights into planetary formation and the early solar system. The moon stands as a testament to the dynamic and often violent processes that shaped our cosmic neighborhood. Section 9. Future research and discoveries. Despite the compelling evidence for the giant impact hypothesis, many questions remain unanswered. Future lunar missions, such as NASA's Artemis program, will collect more data and samples. This will help refine our understanding of the impact and its aftermath. Scientists are also developing new models and simulations to study the dynamics of giant impacts. These models will help us understand the specific conditions that led to the formation of the Moon and its unique characteristics. The Moon, once a source of mystery, is now a window into the turbulent early history of our solar system.